Hello guys and welcome to Geek4Geeks. In this video we are going to talk about downloading and storing Go package. I hope you guys are excited, so let's get started. In addition to the package name, Go program that want to import your package will need to know its package path. The package path is described by what directory you store your package code in. The Go workspace directory is a folder on your computer where all of your Go code should be stored, but by default, the Go workspace will be a Go subdirectory in your user's home directory, but you can change this using the Go path environment variable. So let's take a look at what Go path is set to here in this workspace. Let me just bring up my command prompt real quick and type echo space percentage Go path all in capital tailing with percentage. In this case, Go path is set to point to the workspace subdirectory. The workspace consists of bin, pkg and source at the root. The bin is where all the binary executables are stored. Pkg is where all the packages are stored and src is where the source of the program is stored. This can be also seen as the working root directory of Go programming language. All of your Go code should go in a source subdirectory within this workspace, and then you should create a subdirectory for each segment of the package path. We have set this package under github.com/geeks-for-geeks-project/go-part3 and then the welcome package. We will explain why we use such a detailed package path shortly. Now let's create a Go program that uses this package. To import package into a Go file, you will use the package path followed by the package name. So let's go here into our temp.go file, and as always this is going to run from the command line. So we are going to put this in the main package, and then we will do an import statement. We are going to import a couple of different packages here. So we will use the multi-package form of the import command. First, we will import the format package so that we can use the print line function, and then we will import our welcome package. To do that, we are going to leave the source directory off. That's always assumed by default. But we will start with github.com/geeks-for-geeks-projects/go-part3, and that's the import path, and now we need the name of the actual package. That will be the last segment of our import string. So we will use the welcome package name. I never actually used the content that we imported from that package. So we will create a main function here which will run when our program does. And we are going to call the println function, and we will just pass it some of the constants from the welcome package. So since these constants are coming from another package, we need to qualify it using the package name. So we will say welcome dot, and then we will say the name of our constant, that is English. Remember that English here starts with a capital letter because it's exported. And then we will just copy this and print out Geek4Geeks in Japanese as well. Save that. Now let's try running it. Go run temp.go. And it prints out our two Geek4Geeks, the first in English, the second in Japanese. Now, what if we were to use the unexported constant though? So let's try adding the third println call, and this time we are going to try to access the welcome package in Klingon. But remember, this is an unexported constant because it begins with a lowercase letter. Let us try running this. You see, this time it refuses to compile. It can't refer to an unexported name, welcome.klingon. That means that the constant Klingon can only be used within the welcome package. It can't be used from any package outside it. We can download packages from the web and install them on our system for our Go programs to use. So for example, the Golang team here has an example repository which includes a string util package that our program can use. You will find a link to it in the description below. So here within the string-util package, I can look in the reverse.go source file and see that there's a reverse function that I'd like to try using in a package. So let's try writing a program that uses the reverse function. So I'm going to import that package, which has a package path of github.com/golang/example/string-util. String-util is the package name and everything preceding that is the package path. Once I have imported the package, then I no longer need to use the full package path. I can just use the package name string-util.reverse and I'll pass it the string that I'd like it to reverse for me. So the return value of this would be the string that I passed to it but in backwards. So let's just print that result out real quick. fmt.println GeeksforGeeks. Now if we try to run go run temp.go, we will get an error. Cannot find the package github.com/golang/example/string-util. So first we will use the go command's get sub command to download and install the packages we need. So I'll just copy and paste the package path and the package name right out of my code down here into the console, and I will run the get sub command of the go command and paste that right here. The go get command sees that the library package path starts with github.com. That has no meaning to the Go language, but go get knows that GitHub is a site that hosts Git repositories that it can clone the package code from there. So the go get command downloads the packages from GitHub for us. Now let me refresh our file tree here so that I can show you what changes got made over here. The go get will create a source subdirectory in your Go workspace directory if it doesn't already exist. And then it will create subdirectories for each segment of the package path. So github.com/golang/example and then the string-util package. The github.com/go/example repo also contains several other packages, and Go just clones the whole repo at once. Now that string-util package is installed, we can try rerunning temp.go. So we will go back to our console and type go run temp.go, and this time the package will be found. The program will run successfully and we will see our reverse string as the output. Cool, right? I hope you enjoyed this video. If so, drop a like. See you in the next video. Happy coding till then.